In this video, we're going to look at what happens when we take a binomial and multiply it times some other polynomial. Now, we already did binomials times monomials in the previous video. So now we're going to look at binomials times binomials and binomials times trinomials. We start with binomial times binomial. It says here when we multiply two binomials together, we're going to take the first term from the first binomial and distribute it through to the second binomial. Then we're going to take the second term from the first binomial and we'll distribute that through to the second binomial. Finally, we'll combine any like terms that exist, and that'll simplify us to the final value that we get when we multiply these two things together. Now, there's a little mnemonic that people use for this. I prefer not to, but you may have heard of FOIL. And if you've heard of FOIL, that certainly comes into play here when we're multiplying two binomials together. In fact, that's exactly what it describes, is it describes what happens when we multiply two binomials together. So let's start by taking the first term of the first binomial, and we're going to distribute that through to the second binomial. So we're going to take 2x times 3x, it gives us 6x squared. And we're going to take 2x times minus 4, gives us minus 8x. And that takes care of the distribution through of the 2x to the second binomial. Then we're going to take the plus 3, and we're going to distribute that through to the second binomial. So we'll take plus 3 times 3x, gives us plus 9x, and plus 3 times minus 4, that gives us minus 12. Now you'll notice, when we've done this, that these two terms here are both x terms. They're like terms. And so we're going to add those together using what we've talked about before as far as how we add terms together in a polynomial. And so the 6x squared stays the same. And we've got a minus 8x and a plus 9x. Those combine to make a plus 1x. And then we still have a minus 12. And this is the value that we get when we multiply 2x plus 3 times 3x minus 4. All right, let's go ahead and do that in part B. We're going to do the same thing. I'm going to take the first term of the first binomial, and I'm going to distribute it through to both terms of the second binomial. So I've got x squared times 2x. It's going to give me 2x to the third. And I've got x squared times minus 5. It's going to give me minus 5x squared. And then I'm going to take the plus 3 and distribute that through to both terms in the second polynomial. So I've got plus 3 times 2x, gives me plus 6x. I've got plus 3 times minus 5, gives me minus 15. And I don't have any like terms to combine here, and so this is my final answer that I get when I multiply those two binomials together. All right. On to binomial times trinomial. When we're multiplying a binomial times a trinomial, we follow a very, very similar process. We're going to take the terms of the binomial and we're going to distribute them through to the trinomial. The only difference being now that instead of multiplying it by two terms, we're going to have to multiply it by three terms. And then we're going to combine like terms. And we're usually going to have a bunch more like terms to combine in these than we did in the first type. Alright, so I'm going to take 3x and I'm going to distribute it through to all three terms of the second polynomial. So 3x times 2x squared gives me 6x to the third. 3x times a minus 3x gives me minus 9x squared. And 3x times plus 6 gives me plus 18x. And then I'm going to go ahead and distribute the plus 5 through all three terms in the second polynomial as well. I've got plus 5 times 2x squared gives me plus 10x squared. And I've got plus 5 times minus 3x gives me minus 15x. And plus 5 times plus 6 gives me plus 30. And now I'm going to look at this and see if I have any like terms. I've got some x squareds, a couple of different occurrences of x squareds. And I also have a couple of different occurrences of x's. And so I want to combine those in order to write my final answer. So I've got 6x to the third, none of those to combine with. Then I look at my x squareds. A minus 9x squared and a plus 10x squared combine to make a plus 1x squared. A plus 18x and a minus 15x combine to make a plus 3x. And then I still have that plus 30 out there on the end. And that's going to be my final value. All right, let's do the same thing in part B. We're going to take the first term from the binomial, and we're going to distribute it through to all three terms in the trinomial. So 2x squared times x squared gives me 2x to the fourth. 2x squared times a minus 4x gives me minus 8x to the third. 2x squared times a plus 7 gives me a plus 14x squared. And then I'll do the same with the second term. I'll take that plus 5 and distribute it through all three terms of the second polynomial. Plus 5 times x squared gives me a plus 5x squared. Plus 5 times a minus 4x gives me a minus 20x. And plus 5 times plus 7 gives me a plus 35. And now I'm going to look at this and see, are there any like terms? We see that there are x squareds in common. Those are the only like terms, so those are the only terms I'm going to have to combine. So I write down my x to the fourths, my x to the thirds. Now I combine my x squareds. I've got 14 of them and 5 of them. Those 14 and 5 added together give me 19 x squareds. And then everything else, there's nothing to combine with. And so this is what I get when I multiply those two polynomials together. All right? On the last page here, we're going to look at a little bit of an application of polynomial arithmetic. We see a rectangle here with two unknown side lengths, one of which is 3x plus 5 inches, and the other which is 2x minus 7 inches. And this question asks me to do two things: find the perimeter and the area of this rectangle. Now, if you remember, perimeter is the measurement that we get when we measure all the way around the outside of a rectangle. And so we want to add the lengths of all four sides together. Realize, since this is a rectangle, that this side is 2x minus 7. And this side is 3x plus 5, because the opposite sides of rectangles are the same length. And so to find the perimeter, I'm going to take all these sides and add them together. I've got a 2x minus 7 side, I've got a 3x plus 5 side, I've got a 2x minus 7 side, and another 3x plus 5 side. And I'm going to add all those together. There is a shortcut way to do this. Just multiply each side length by 2 and then add that result together. You're certainly welcome to do it that way. I probably would. But I find that a lot of students prefer to just go ahead and list out the sides. And now we're going to combine the like terms. I've got all my x's. 2x plus 3x plus 2x plus 3x makes 10x. And then I've got a minus 7 and a plus 5 and a minus 7 and a plus 5. And when I add all of those together, it gives me minus 4. Now, since it's perimeter, we think about what units is perimeter measured in. And perimeter is measured in inches. So this is going to be 10x minus 4 inches. All right? Really didn't require any multiplication like we did today, because all we were doing was adding all the lengths of the sides together. Okay, part B, find the area of this rectangle. Now, if I want to find the area of this rectangle, remember, area is length times width. And so we want to take the length of the rectangle and the width of the rectangle, and we're going to multiply those together. And now we're going to use our polynomial multiplication. 3x times 2x gives us 6x squared. 3x times minus 7 gives us minus 21x. And then we'll distribute the 5 through both. 5 times 2x gives me plus 10x. 5 times minus 7 gives me minus 35. And now I combine my like terms. And this works out to be 6x squared minus 11x minus 35. Now the units on this, when length is measured in a particular unit, area is measured in that unit squared. So, since our lengths are measured in inches here, our area is going to be measured in inches squared, or square inches. And that's going to be our area. All right. Talk to you next time.